Yeah, exactly. Now that the stream is on, I would like to shame a couple of my coworkers that did not want to come out tonight, but did say that they were interested in the stream. So, guys, I'm putting the link if anybody can actually hear me that had my link from last time. Put my link in my Teams channel here, and all right, let's go there. All right, cool. That looks like it's working. All right, and I'm gonna get my notes out here. Okay, cool. All right, so you're in the right place if you're looking for the Frederick.net meetup. I certainly appreciate you guys coming out. Machine learning, or maybe the cat in the toaster on the image, piqued your curiosity and led you to want to come out. I'm David. You guys, I'm sorry, I didn't get your name. Richard?
David.
You're David as well. That's right. We met. We talked either at the last meetup here or.
It's been a couple of months.
Yeah, but thanks for coming anyway. Cool. So we're going to talk about machine learning. We're going to be doing some image classification. We're going to go over some like generic terms, things like that. If at any accelerator. So it was a Jan Gardner vision, that kind of brought this place together. They started in biotech. Now they're kind of branching out into technology companies in general. So if you have some kind of idea, you want to start a business, something like that, you can come set up office space here for really, really cheap. And you get access to all kinds of different tools, legal, financial. Kathy's a great fundraiser. She's a fantastic networker. She can put you in touch with the right people for sure. So thanks, Fitzy. And then lastly, we were talking about Tech Frederick really briefly. So Tech Frederick's a nonprofit in the area that is focused on more tech in Frederick, making people aware that starting a business here, a technology company here, is not a bad idea. There's actually a lot of incentives, to do that in a place like Frederick. And if you're a job seeker here, then you really do not have to commute down to DC or go to Baltimore or something like that for a decent technology-related job. So Tech Frederick's just kind of fostering some of that growth, and I just wanted to kind of mention them here. So we're here for machine learning. So this was similar to a slide in a recent presentation that I did. With just a little bit of a couple of quick tweaks. So is machine learning just a buzzword? There's a lot of companies that think they're checking the boxes or want to check the boxes that they're doing AI, machine learning, what have you. But are they? Hopefully this, tonight's presentation will shed even a little more light than last time on whether or not you're actually doing machine learning or if you're actually just automating something. Machine learning, is a data science technique. So given a bunch of data, can I answer some questions? So the 5 main questions that I like that as I go through my machine learning education, is this A or B? That's a classification. So is this a cat or is this a toaster? If I have a bunch of images or something like that, is this going to result in a sale? Is this not going to result in a sale? If you're dealing with hard numbers in your data or you have some type of inputs that you want to dump in. Is this weird? So anomaly detection. So you may have a system that just logs a ton of data and you want to know, you see there's a gradual change that you suspect might be there, or you see some kind of, some type of thing that might look like periodicity or something like that, but you want to ask, in a more sophisticated way, is this weird? Last time we did a presentation on regression when you want to answer the question how much or how many. So you want to make some type of prediction based on a bunch of inputs. We had inputs, that were a bunch of statistics of diamonds, and so we wanted to make a prediction of the cost of a diamond just given its traditional inputs, cut, color, clarity, and things like that. How's this organized? Clustering. So if I have a bunch of data and I can't really identify distinct groups well, I think that maybe there's a lot of overlap, or I can't quite tell exactly how something's organized, and I just have too much data to visualize whether or not it's clustered. I could leverage a machine learning task to tell me whether or not something is organized, and it could even organize it into various groups for you. You could think of that as an example. One example of that might be customer segmentation. Maybe you have a ton of different customers at iHire on the job seeker space, and you don't know exactly. Maybe there's a bunch of cliches or clicks or something like that within that, or a bunch of cohorts within that those users, and you're trying to figure out how they behave. Maybe there's a group of them that's behaving similarly, and maybe it's a larger group than you thought. So how is it organized? How can I lump them in and maybe market to them better or try to sell them something else? Last one, which we're not going to touch on at all today. What should I do next? Reinforcement learning. So it kind of ties into a lot of them. Reinforcement learning is where you're continually feeding data in and trying to make decisions with your system. So the former of what I just mentioned, it means that you're constantly growing your model and making better predictions as you move on. So those are the 5 questions that machine learning tasks really answer for you. Tonight we're going to be working on classification. It's not limited to A or B. Our example tonight is limited to A or B, cat or toaster. But you, with increasing amounts of data, you could lump in feed in whatever data you want to the system to make the same types of predictions. The more data you have, the better your predictions tend to be, or at least the more accurate your data is, the better your predictions tend to be. But tonight we're just going to be doing a binary classification as opposed to a multi-class classification.
David, on
Yeah.
your bullet of use existing data to forecast,
Mm-hmm.
how might today's machine learning be different from the way we used prediction 10, 20 years ago to predict forecasts, right? Because they were doing forecasting on the stock market data, 20, 30 years ago. How might ML be different from the way it was done in the past?
My guess is a lot of it was probably just simple regression. It was basically the line of best fit that you learned about in Algebra 1, Algebra 2 while you're in middle school or high school. And they're with computing systems 20 years ago, you could feed that data in, and with pretty rapid results, you could get really good extrapolation. Whether it was accurate or not, I think is up for discussion for sure. Most stockbrokers, claim that they have no idea what they're doing anyway. Like they're going to tell their customer that the price is going to go up or the price is going to go down based on some sophisticated model that Goldman Sachs or whoever came up with. But I couldn't really speak to that real specifically. So maybe it was just regression because that really is kind of it's basic math in the grand scheme of things. Whereas what's happening now with recurrent neural networks and things like that, it's a lot more sophisticated. The level of complexity is a lot higher than what computing power was even capable of 20 years ago. Now that processing power has become so cheap, it's a lot more accessible. So feeding a bunch of data in.
Computer equipment to forecast the stock market.
Yeah, if you've got that kind of money, maybe you could throw this type of power at it. Now, this type of power is available free or cheap in the cloud. So we're going to be building a prediction engine in Azure tonight that we're going to hit. Now, we're using a free tier, so we're throttled. We're only going to be able to make a certain number of requests per time interval. Whereas if you want to get into a paid tier, you can train your model a lot faster. You can make predictions a lot faster. But we're still talking about like the next tier up is like $10 a month. To get like hundreds of thousands of predictions or something like that. But we'll touch on that when we get there. So I don't know if I've fully answered your question, but that's my guess.
That's what I was looking for to see if it was any different. But I think the answer is that really we're getting better, faster, cloud-oriented, better, accurate models.
And if you want to spin up a supercomputer for an hour, you can these days. That's something that we can literally do in this room, where before we needed access to an institution or something like that. Now, I can jump on Azure or AWS or whatever, and I can spin up, a bunch of X1 instances or whatever. I think that's what it is on AWS. I think that's one of their higher end compute instances. And I can spend $100 for an hour of that time, and then I can just tuck it away because I can blow the machine away and I'm done with it. So I think maybe some of it's accessibility, and I think some of it is also sales magic, people that are in biz dev and things like that. Oh yeah, we've got these sophisticated machine learning models and things like that, or artificial intelligence, when realistically all they're doing is, finding that line of best fit.
So it gives you liberty to call everything machine learning because, they used the math model in a limited fashion years ago. We're just improvement now and called machine learning.
Yeah. That's my best guess. I mean, I think that is it's just more accessible these days. So the availability of it, and it's cheap. Startups have no issues, spending $10 to experiment on something where 20 years ago it may have taken, if like venture capital was even a thing, then you may have had to find $500,000 or something like that to stand up the machines to make these advanced predictions and things.
Investment, like I'm familiar with, a rich guy with some money would just get a bunch of computers and hire a bunch of smart.
There you go.
Computer programmer tech people, and then they would try to build something.
And Microsoft, Google, and Amazon have all taken advantage of that model because now they're the rich guy and they're loaning out all their computers. All right. So just some vocabulary. So just in case I say things as we're moving throughout, like the tool demo. So we talked about classification. That's what we're going to do tonight. We're going to build a supervised machine learning model that's going to predict A or B given an input. So that was not in the original training data set, basically. So we're going to use a bunch of pictures of cats and a bunch of pictures of toasters. And then we're going to use a picture that of one or both or the other that we did not initially feed into the classification system to make a prediction. Label, that's the thing we're predicting. That's just kind of a terminology that I've noticed that is platform agnostic. Doesn't matter if it's TensorFlow, ML.NET, PyTorch, pick your ML language or platform. Label is the thing that we're going to be predicting. Multi-label, if there are multiple classifications per input, that's actually not what we're doing tonight. So that would be if we wanted to give a percentage of confidence for a cat and a toaster in the same image or something like that. Multi-classification, that's one classification per input. That's actually what we're doing. So we're going to have one classification per input. And what we're going to see once we get into the nitty-gritty of it is that it's basically going to be a 100% certainty, which won't always be the case, and I'll talk about that, that this is a picture of a cat, or a 100% certainty that this is a picture of a toaster. The model itself, so this is the thing that we're going to train. One of the cool parts about the custom vision API that I'm going to demo for you guys tonight is you can export this model into different systems. ONNX, you can export it into TensorFlow, so that you can use it in other systems. So once the model is trained, you can kind of think of it as a black box of metadata, and you can feed an input in and see what it spits out on the other side. This was just something that I had, the data curation bullet point that's here on my slide is something I had from my last presentation. It's basically magic. In this case, it's actually not magic. I just Googled a bunch of images of cats and toasters, used an image downloading plugin. So there's a couple hundred of each one or whatever it is. Last time, the data curation was a lot more important because the features of the diamonds and things like that I talked about last time needed to be in a specific shape before we could make good analysis of them. So that's what we did. But a lot of machine learning ends up being data curation. You have to have the data in the correct shape before you can feed it into the engine. And as we saw in my last presentation, there were about 50 lines of code. I think it may have even been less than that, that did the entire machine learning part of it all. We're not actually going to be writing any code. I'll show you guys some code that I attempted to write, but the API I think was in a shift, or I just couldn't make it work. There are APIs in ML.NET that you can write some C# code and hit the prediction engine. We're just going to be using a software called Postman to generate an HTTP web request to the Azure Custom Vision API that'll feed us a result back. So that's one of the assumptions, is that you have a free Microsoft Azure account and Postman, or theoretically you could do this using curl from the command line if you wanted to. It's just about having the right header and your API key and things like that, which we'll talk about once we actually get into it.
Do you have the key for the FIDI guest account?
I think it's guest @Fitzy, all lower, no spaces. I think that's what it is. So classification, is it A or B? This is similar to a slide I showed before, a slide I showed in my last presentation about what it's doing. So with some degree of confidence, we're going to say that all of our objects are on one side of the line or the other. You're either a blue dot or a purple cross in this case. In our experiment that our model that we're gonna build, the line will be whether or not you're a cat or a toaster with confidence. When you get into multi-label classification, it's a little more complex. The internals of it are a little more complex. The actual results are not. The results you get are just going to be, I am 80% confident that this is a cat, but I also put a 20% confidence that this is a toaster. And again, since this isn't just binary classification, it can apply. So in this particular system, there may be 4 different tags, gray dots with orange outline, black outline, blue outline. So maybe those are just the 3 in this particular case. But there's a lot of overlap. There are some that are directly on the line. So this is just kind of a visual representation of what the math might look like behind the scenes when you're talking about, well, I'm 80% sure that it's this, but there's a 20% chance it could be this. We're just doing a multi-classification or a binary classification tonight. The data. So how did I actually come across this? I literally Googled pictures of cats and toasters, and I used a batch downloader extension in Chrome to grab a bunch of image assets and dump them in. So there's no real magic to this. The important part when we go to test this is just to try and use a picture that was not in this data set to gain confidence in the system. If we were to use this gray cat over here, this exact image with the exact dimensions and all of that, there's still technically a chance that it could predict that it's a toaster, but it doesn't really it doesn't really test our use case. I meant to put something in the meetup. I thought about it on my way over here. I should have asked people to bring like pictures of their cats, because not that many people probably have pictures of their toasters, readily available that you can get to me. Fortunately, I've got some test images that I can promise are not here, not in the original data set. So when we get there, we'll demo how to go through that. I'd be interested to see what it actually turned up. Some of these things are pretty fascinating. Systems or models that we train with more than just A or B. It's interesting to see what it is. I'm sorry, there was one more thing that I wanted to talk about, and that was image detection versus image classification. We're doing classification tonight. We're not doing image detection. Image detection would be detecting an object within an image and then displaying its bounding box, for example. So if I had a picture of a cat and a toaster in one image, image detection would be able to tell me there's a square here and this is where the cat is, and there's a square over here and that's where the toaster is. That's not what we're going to be doing tonight, but the Azure APIs and the Custom Vision APIs do support that. All right. This is just a real quick and dirty list of steps. I have a couple of duplicates of this slide as we go through this checklist and move through the presentation. So we're going to pretend that we've acquired a ton of images. I waved my hands and they're ready to go. We have a free Azure account. We can do all of this under the completely free tier. Again, as I mentioned earlier, it is just throttled a little bit. So next we're going to create a custom vision project. What does that mean? That literally means nothing more than going to customvision.ai and logging in. You'll be able to log in with your Azure account, and you're going to be presented with a list of your projects. You won't have any projects to start off. This is my fallback project, the one that works, just in case this doesn't actually do what I think it is, what it should do. But I'm going to create a new project so we can go through the entire process. So I'm going to call this one Meetup Demo. This is the resource group in Azure. It's just a logical container for where you can put things in Azure. You don't actually need to know much about it for the purposes of this presentation. We're going to be doing classification. I just talked about detection a moment ago. We're not going to be doing that. We're going to be doing classification in this case. We're going to be doing multi-class, not multi-label. That is, there's going to be one tag per image, and that's a cat or a toaster. And I just want to point out these. We don't actually need to change this for the purpose of this demonstration. These duplicates down here, general, food, landmarks, retail, these are some domain areas that Azure Custom Vision already supports for you. The difference in the compact versions is that they are exportable. I mentioned a moment ago that you can export your model after you train it to TensorFlow, ONNX, and a number of others. You can't do that if you're just using the non-compact ones. I'm not exactly sure why.
You don't know what the compact means?
No, I'm telling you that if you want to export your model into TensorFlow, for example, you have to use general, compact, and not general. General, the ones without the compact parenthetical, they only live in the Custom Vision API on the web, so I don't believe you can do anything with them in ML.NET or TensorFlow or anything like that. You have to rely solely on what's available in the cloud after you build your model.
Those are not a checkpoint for the model.
What?
Pre-trained model and all
Correct. So if you wanted to retrain your model and then export it and use it in some other system, let's say you wanted to export your TensorFlow model for a mobile application that you did not want to have, that you needed to be offline. So you needed the model to work when I take a photo with my camera, but I'm in a dead zone and I have no service. So you need that model exported in a compact way that can go live with my cell phone or with your mobile device. The first four that are here, general, food, landmarks, and retail, they only live on the web. So you would need an internet connection to be able to access that model. The compact version, there's something else that's done behind the scenes in custom vision that will allow you to export that into literally a file, like a TensorFlow PB file or whatever it's called.
Probably a pre-trained, so they're probably a pre-trained model
Probably.
that has the classifier. Are they pre-trained then, or not?
Once you export them, they're trained for all intents and purposes.
I mean, a trained one's going to have the neural network classifier built in or part of description. Like it's all in text. I mean, it comprises in text, but it's the classifier model description. It would be the gradients that are all recorded in the state model. So there's state, the dictionary, right? So the state dictionary would record all of the gradients in the model that it was trained to. And so when you download that and you start to train it again, you're starting from that pre-trained model state dictionary.
And we're actually going to go over some of that. So I'm going to have to defer to you on that one. I'm just going on based on what this tooltip says. So pick the domain closest to your scenario. Compact domains are lightweight models that can be exported to iOS, Android, and other platforms. So that I'm just picking this so that I'll actually be able to show you where the export button is in the web portal, in the Custom Vision web portal. And then down here, export capabilities, I'm just going to say basic platforms because I'm not using the Vision AI dev kit. I'm actually not even really sure what that is. But we will have the ability to export any of our trained models to these various platforms.
Is this the same? This is really coming off of Azure?
Yes. So Custom Vision is actually one of the services inside of the Azure Cognitive Services suite. So there's lots of other Azure machine learning-y, artificial intelligence-y APIs that are there, like sentiment analysis and all kinds of other things. CustomVision.ai is just a domain that they have that interacts with this. So what this is doing right now, assuming it's actually working, is this is building out a project inside of my resource group in Azure. And it's just allocating that actual resource. I'm not sure if this is actually working or if I still need to wait. I just tested this process the other night, so this step was notably faster. I'm gonna come back to just the project. Well, I wonder if we can add images already. All right, let's give it a shot. Cool. I'm not exactly sure. Usually it presents you with like an empty project screen. I'm not sure why the loading is still there. Yeah, follow these steps to build your first model. That's helpful.
Yeah.
I wonder if it's because I'm mirroring my display, or sorry, I'm broadcasting to the 3 different HDMI's, and I also have OBS streaming on this particular screen. I wonder if it had something to do with that, but refreshing it should have done the thing. Let's go back to my home, and I need to switch my directory.
Does your labels have the type of dog or just is this?
Nope, just cat or toaster is all it is. All right, cool. So we've got the project. There we go. So the loading is gone. Here we go. Cool. Looks like you don't have any images here. Add images. So in this particular case, we're going to pop back over to. I just want to make sure that we're doing all of this in the right order.
You don't have to log into the Azure dashboard then.
Nope. This has done all this for you. If you want to, you can go see the actual app live there if you want, but you don't need to.
I mean, you created that app?
So I logged into CustomVision.ai with my Active Directory credentials. So with everything that would be used for Azure and all of that. So, and I have permission on my subscription to add a resource group and add any kind of resources to that resource group. The resources that it creates are 2 actually. It creates one for the training API and it creates another one for the prediction API. We're only going to be accessing the prediction API, but the training API is all handled behind the scenes here through the Custom Vision web portal. But no, you don't actually, for our demonstration, we are not even going to log into the Azure portal. We're staying pretty high level with this. So I'm going to add images, and
Will you be able to predict, choose the type of model that you're using to predict off of?
no, not specifically in this case. But if we're training using actual ML.NET code, which I'll show briefly at the end of this, it's the code that I mentioned I couldn't quite get to work. I could get the model trained, but I couldn't get the prediction engine working. I think it was probably like a bad HTTP call or something like that. But that's what it amounted to.
When did you pick which model it would be using for the prediction?
I didn't.
It's choosing for you.
Yep. The custom vision API is doing a lot of that for you under the covers.
I see.
Yeah.
Kind of stuck with what you defaulted to from Microsoft's custom vision.
Right.
API.
If you're using ML.NET, you can train your model in a different way. If you're actually training the model at a lower level, like writing some C# code, you can train your model like that. But through the web portal, if it's there, I just don't know where it is. Maybe it is.
Well, because your prior screen, you showed the models.
Those were not training algorithms. Those were just formats of models to output to. So if your system only supports TensorFlow, then I can generate this prediction engine in TensorFlow format. It's not specific to use this type of gradient descent or use this type of stochasticity or something like. It's none of that, to my knowledge. That's just the ability to export it into a compact format in case, again, you need an offline version or you need a self-contained version or something like that. So here, not doing anything fancy. I'm just uploading a bunch of pictures of cats. Hopefully this only takes a moment, and I'm going to add a cat tag to these 263 images. It'll take its time uploading. So we haven't done any model training. We're doing nothing more than just uploading images and tagging them with one tag. We're going to do this again in a moment, and we'll upload all the images of toasters. I wanted to use a much larger data set, but I wanted to show this process to demonstrate how ridiculously easy this is to get started with. I don't think there are any limitations to the number of files you can upload, though. If you wanted to upload like 1 million files in this UI, I think you can. It's going to take some time, but I think you can. I don't know if they have any plans to support like zip files or anything like that, but cool. So we've got 260 some odd pictures of cats. We're going to go add some more images, and I'm going to go back up to pics for ML, toasters for ML, and now I'm going to upload all of my toaster images. 311 of these. No particular reason. I went through, scrolled down a bunch so that my browser plugin could see several hundred images, hit download, and just took whatever it gave me. So it's entirely possible that there are some pictures in here that are not of cats or toasters, but I'm going to default to Google being pretty good with that kind of thing. I think there's reasonable confidence that these are all cats and toasters, but I haven't specifically curated like 500 images. So again, nothing going on here other than uploading the photos to the Custom Vision API. It has not done any training or anything like that yet. All right, whatever, 10 images failed to upload, so maybe they were just bad images or something. But we can scroll through all of our different images, and now we're into the cat section, so they're all here. At this point, we can literally train the model. So there's an advanced training right here. Maybe that's where the actual, nope, that's not the difference in algorithms. We're not going to use the training budget because we actually don't have, one, we don't need it. Our model is going to train pretty quickly. They name them by default, iteration 1, iteration 2, etc. That's going to be important in a second when we get over to making the web request to say, hey, prediction engine, here's an image of something, tell me what you think it is.
Is this training engine using a subscription service that's part of using the GPU to do the training with so that it does it fast?
I have no idea. That is all black box to me. This is just using whatever Custom Vision API has decided to implement by default. When I went up to the advanced training, I'll show you this screen again. You can establish a training budget. And this is something that you're going to pay more for that compute time. So if you did have some massive amount of data that was not going to train as quickly as what we just got, because we only had 500 images that, largest image is probably 50K or something like that. Didn't take a lot of time to upload, didn't take a lot of time to analyze. But if we had 50,000 images of cats and 50,000 images of toasters, I imagine the model would probably take a little bit longer to train, and it might be slow in the free tier, and I may have to actually establish a budget to train it faster by paying a couple dollars.
And did you notice that whether or not, so the free tier that you're using gives you, like, so does it give you enough prediction percentage? What is the prediction threshold that you think you get with the free? Can you get better than, 95? Can you get 95%?
Oh, no. You're not paying for precision or paying for like better prediction. You're paying for compute time and the volume of predictions that you want to make. In our scenario tonight, we're going to make a prediction of, we're going to need to make like 6 predictions. I have 2 pictures of cats, 2 pictures of toasters, and then I have 2 pictures with a cat and a toaster in them. And that's it. You can do, on the free tier, you can make 2 predictions per second is what you're throttled to. As far as the actual training goes, to train your model takes a lot of compute time. Again, let's say we had 5 million images of cats and 5 million toasters, that's not going to be trained, I thought there was a time here that it showed. Maybe that was in an old version of the UI. It's not going to train in seconds. You're going to need hours upon hours upon hours, and you need to establish a training budget that you're comfortable with, because you may not want it to train everything right now. You may want to give it, an hour a day or something like that to train, to control your budget. Because on cloud services, as some of you may or may not be familiar with, you're paying per second for a lot of things. So if I did have some massive amount of data that I needed to process, I may want to throttle that training, because I don't want to pay for everything right now. Maybe I'm a startup and my budget is low, or something like that. Does that kind of answer your question?
Yes, but then these 99% numbers, this can't be, I'm not seeing how these are your prediction percentages then, because, like if you do a training stuff I do, you get 97%. Maybe once you train for 15 epochs, but to get 99%, what's the percentage?
That's what it is.
99%?
Yes. So even just with this small sample size, with this binary classification, and we'll see when you get here. You can feed as many. We'll go Google for some more images, and we'll feed some more in. So the number will tell you if a tag is predicted by your model, how likely it is to be right. 99.1%. This number broke 100%, like came down from 100% in my experimentation with this after I had about 100 images each. So I went through and created this project a number of times to go through and just kind of see how a fresh model would look with varying numbers. It was at 100% early on. So I don't know if that has something to do with a really tiny data set, or maybe it's the difference in cats and toasters and just like the average image that we have in the set.
Between cats and toasters, though, not cats and dogs.
Exactly. So maybe there's a big difference there that it can distinctly tell. Yeah. So
I would think it would be. Did you do this on cats and dogs?
I have not done this on cats and dogs.
Okay.
So what you're saying is that if it were cats and dogs, this precision after 500 images would be much lower.
95, 97. I don't see any way of being 99%.
Sure. I think I have an image that actually violates it. It's a picture of a cat that it classifies as a toaster, which you'll see. So it's definitely not foolproof. And like general rule of thumb when you're talking about data science is more data is usually better. Not universally true, but usually better. So in any event, so this was iteration 1 of our model. In this case, we could export the model right here if we wanted to. So I can export this to, I'm not even familiar with Core ML. I don't know if this Docker file means that this just outputs a Docker file that hosts it. Maybe that's what it is. ONNX, TensorFlow, and Vision AI Dev Kit, which I think might still be in a beta. But in any event, we're not going to be exporting. We're just going to be accessing this through the Custom Vision API. So the next thing we're going to do is run a quick test prediction in the cloud. So we're going to quick test this, and I'm going to grab, let's see, test cat 01, This was one that was not in the data set. 100% probability that it's a cat. And then we'll just want to test real quick before we actually publish this. Oh, you can also hit the API with URLs as well if you don't have the images handy. And then we'll go with test toaster 01 and 100% a toaster. Now what we're going to be able to do, to make this accessible to the web, it just gives you a report. You can track these quick test predictions if you want to online. We want to access this through some kind of API. We want to be able to do this in rapid fashion. Well, we don't right now because I don't have the budget to do that. But I'm going to show you how to make a quick web request to be able to feed an image up and make a prediction based on this engine. But the first thing that we have to do is actually publish this and give it a name. I'm just going to call it iteration 1. That just ends up in the URL structure. Excuse me. It ends up in the URL structure when we're actually making our post request to say, here's an image, tell me what this is. And it returns some JSON with the probability and that kind of thing. The only other thing that we need are the API keys. There's a couple different ways to do this. If you go to prediction URL, it'll give you a quick and dirty example of if you have an image or if you have an image URL or an image file. I have no idea what I just did. Must have clicked something or dragged my fingers in a way that confused it. Has the prediction key header to this value that I guess does not display here. If you go up into your settings over here, I'm going to torch this project after the meetup. So in case there are thousands of people that are viewing this stream online right now, ordinarily your keys would actually show up over here. And I wonder if this still has something to do with the stream. Everything is right over here. All you basically need to know, it has an API key for your training endpoint and it has an API key for your prediction endpoint. We're not actually training using the API. We've already trained our model and it exists at a URL. The only thing that we need is that API key. So at that point, this is where you would go to get it. Again, I don't know why those aren't showing there. And this is usually, actually I can show you a slide. If I can find my mouse. I had a slide with everything blurred out right here. So this is what that right section of that page looks like. There's a prediction key, a prediction endpoint, this resource ID you don't need, and it'll tell you how many predictions you have. So you have 10,000 until it resets. I believe that's monthly in the free tier, but you're also limited to 2 transactions per second in the free tier. So you can't just bombard this thing with 10,000 predictions without bumping up to the next tier or standard tier or whatever it is. But that prediction key that's blurred out right here, that's what you actually need for this in addition to this URL. And then if we pop over to Postman or choose your favorite, come on, oh, where'd it go? I'm trying to switch monitors here. There we go. So again, Postman's just a tool to emulate or simulate or create, get, post, put, delete, whatever requests. In this particular case, this is the URL that it's going to hit. EastUS, API, Cognitive, Microsoft.com, Custom Vision, blah, 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 blah. This means it's hitting the prediction API. This is my project ID. So this was all over the URL that we were using in the customvision.ai website. We want to classify, we want to use iteration 1, and we're telling it that we're passing it up an image as opposed to a URL. The other keys you have to have are a couple header values. I don't think that this is supposed to be form URL encoded, but this prediction key is key right here. So I have an actual value that's there. Postman just allows me to store variables. And then the other thing you need, so that's the actual API key that's there. And then in my body, I just need to pass up an image. I'm going to pass up test cat and toaster 01. So this is a cat and a toaster in the same image. I'm going to run that guy. And with 100% confidence, it's a cat.
You're not doing any transformation or processing of images at all.
Are you asking? I'm not sure what you mean.
You're not cropping the image in any way, right?
No. So that image, I can show you. Well, you could actually see it right there when I was like choosing the file. This is a file that was an image that was not in the original data set. So it's this cat sitting on top of this toaster. but whatever the custom vision API knows in this binary classification, it can say this is a cat or this is a toaster, not both.
Well, I mean, in this case, it's probably just thinking that toaster's a table with cat sitting on.
I'm not sure. I would not presume to know what it actually thinks, but yeah, sure. I mean, it could think it's anything. Maybe there are just more pixels that were closer to cat, and whatever training algorithm it's using, it's saying, yep, this is more cat than it is toaster, and it can't be both, so I'm going to defer to cat.
Well, see, this is the issue that brings up in today's problem with machine learning, which is
Absolutely.
you don't know why it's choosing the cat
Exactly.
or not, and why it's not choosing the toaster.
There's so much metadata that comes out of these machine learning algorithms. More often than not, I read blog posts and things like that about data scientists that wrote an algorithm or built a recurrent neural network or whatever it was, that they can't explain what happened when it went wrong, because the amount you need another machine learning algorithm to process the metadata to tell you what it actually did, because it's just so ridiculously complex. So yeah, you're absolutely right. That is absolutely a very ethical question or conversation that's happening today with machine learning, because of various screw ups in the past already that we've seen. Google, Microsoft, Amazon all have had major AI blunders, blunders that have been in the public space based on an algorithm that was supposed to do something really well, but that 0.1% of the time that it did something poorly, it did it really poorly. Microsoft had a bot called, I think it was called Tay, and they trained it based on all of the data from Twitter. Within about 6 minutes, Tay was basically the most racist AI you've ever heard. So they had to shut it down, because they were like, well, we're just going to feed Twitter in and it should be able to kind of parse things out about the English language or whatever it is. Turns out, the majority of Twitter, or however the AI analyzed it, just thought that being racist was the way to talk. And, they had to shut it down. Google had that incident.
Because I just heard a comment last night from a Microsoft person, I'm not going to name names, that indicated that maybe the government using ML, machine learning, shouldn't train on just government data. They should train on the internet.
Absolutely.
My
Yeah.
comment problem is just what you're saying, in that the likelihood of them getting
The internet is
social networks
unfiltered.
being biased or racial or other biases,
Exactly.
right, could twist their data, and so therefore they really
Yeah.
are probably going to be hesitant to open
Yeah.
their data set
These things
to
are
the internet.
these things are doing pretty sophisticated things behind, under the hood, behind the scenes, whatever you want to call it. And you're right. There's just a lot of metadata, and we can't predict well, without a lot of post-mortem analysis, why it did what it did, because they're so sophisticated. So with binary classification, it's very dangerous. I was just getting ready to mention Google was another provider that was in the news 5 or 6 years ago. I hesitate to say early in the machine learning days, because it definitely wasn't, but they unleashed an image classification algorithm on Picasa, their users' photos, and they unfortunately pretty quickly out of the gate, as I recall reading about it, were classifying human faces, and they were trying to do facial recognition, with a bunch of different things. And unfortunately, a number of African Americans were classified as gorillas. And it was huge news, because that obviously the algorithm was wrong, but with the data that it was trained on, that was what the computer model was supposed to say, or not supposed to say, but that's just what it ended up saying. So there've been a lot of public spotlight blunders, I think. This is just a really, really quick and dirty demo to show you how easy it is to at least start with it. So for the second test here, I think this is the one that came back as a toaster. So this one, the cat and the toaster are, oops, that's not what I meant to do. I meant to send that. Oh, it got rid of my file. I need to pick my.
That one clearly has the open top of the toaster where the bread goes in, and the cat can be misconstrued as a rug or as a towel.
Certainly could. I thought this was the image that was going to be classified as a toaster, but it does look like this one. The probability on this one is cat, and it's extremely well. That's interesting. I thought that this was going to be. I thought the reason that it was so low before. This is actually two orders of magnitude better than the last number that we had in here. The last prediction we made. It was like times 10 to the negative 12th or something like that. So I'm surprised because I thought these were supposed to be 100% one or the other, but it's telling me that there is at least some probability. But even in that image, it still was able to see. So this was the second test. There's still way more cat in there than toaster, but what was it actually? Was it able to detect some type of like facial feature here in like the face of the toaster, and maybe that's why?
It would be
Hard to say.
interesting to see whether you made the cat smaller in the picture than the toaster.
That's
to see
interesting.
what the prediction would turn out.
Yeah, I wonder if they're like go through some like set up some Photoshop macros or something to like edit a photo and like continually shrink like the cat area of the photo and see like how the algorithm actually changes to get some post-mortem. And it actually illustrates the point we were just talking about how it's so hard to determine what that metadata looks like to say, hey, I know my algorithm did wrong and I know why it went wrong. I'm not hearing the latter part of that conversation much at all these days. It's, well, it went wrong and we'll figure out one day why, what happened. Maybe as we get closer to quantum computing, that will start to change. Who knows?
If you go back to that first image where the cat was on top of the toaster,
Yeah,
will the probabilities change?
they definitely did. Sorry if I ran that too quick. So I'll upload this one again.
You could make your own set of data.
So with this one, it was 100% for the cat, but then this right here is just telling me that it's infinitesimally small the probability that it was a toaster. With that second image, this one says with 100% confidence to me, but this is technically not zero. Maybe this is javascript.min or something like that. Maybe that's what it's trying to represent behind the scenes, and that's why it's returning it. When you're consuming this API, most likely you're not going to be looking at a number that small. You're going to discard it. You're going to say, okay, it's either 90-10 or 99-1 or what have you. In this case, I think we can say with a reasonable probability, it's a cat. Whether or not we should be able to say with reasonable probability that it's a toaster, kind of left to be determined. Or maybe, like we were talking about earlier, maybe it just means we need a ton more data. We just need we need millions or tens of thousands or hundreds of thousands of images of cats and the same complement of toasters to be able to really get that confidence. And even then, if it's a binary classification, which one's correct? So in this particular image,
If you were able, you'd have to do it in part of a little custom interface, but
Mhm.
if you were to run a transformation function so that you either transforming can mean, okay, I'm going to crop half this left side of the picture, I'm going to crop the right side of the picture, and it becomes two pictures, right?
Yeah.
And I run the prediction once on the left side, and I run the prediction right again on the right side. So that's a simple way of maybe very crudely taking the pictures and seeing
Definitely.
object detection sort of in a crude way, or identifying, in fact you could transform the image, could be the top left, the top right, the top bottom, the top lower, right? 4 images, and crudely re-predicting and seeing if any of the 4 sections of that image become a toaster or a cat, right?
Right, and that actually gets into image detection more than classification, where you're actually trying to establish a bounding box of an object within an image. So the images that we use in those last couple examples are probably better for image detection model, where it would be able to say, all right, I have 60% confidence that there's a cat right here, and I have 80% confidence that there's a toaster right here in this particular, just all within one image. But then that begs the question, should you be feeding it images of just cats and just toasters separately, or should you be feeding the model all images of cats and toasters so that it can determine, I don't know, I can't speculate on which one would be better. This is just kind of, my show and tell for what I've learned throughout this process. And the custom vision API struck me as really, really simple. The only reason it took, a half an hour or so to go through it this time is just because we were walking through each one of the steps. But at the core of it, we could redo that with any number of images. I could go grab 50 different types of images from 50 different random Google searches, maybe 500 or 600 a piece, take, 10 minutes to upload them all and that kind of thing, and then run some predictions, feeding some new images in. So this was just a quick recap. So that was basically it. So that was the entire presentation as far as what we were doing, how to do it cheap, when it might cost you, and then how you can actually make a prediction based on the model that you generated. There was just a slide from there. So classification, supervised machine learning technique. That means that supervised meaning just that we fed it images, we didn't feed it arbitrary data and let it learn on its own. We trained it, we taught it, we did whatever. Glenn asked a good question earlier about what algorithm or what training model it was using, and I don't have the answer to that, but there are ways to specify that type of thing through the training API, but the custom vision.ai portal obfuscates a lot of that for you. So cognitive services, that's the overarching umbrella that Custom Vision belongs to, and customvision.ai is the portal. We talked about the pricing differences between the free tier and the next tiers up. So throttling and compute time are the big ones. How to actually train a model and publish it, and then how to predict using a published model. I'll definitely post the slides online. So I comprised a lot of this from these links and probably a couple other ones. This one right here, github.com.net, this is the primary .net repo, machine learning samples. This one is fantastic. There's a lot of really, really great examples right out of the gate in a lot of different domains that you can get started with really quickly. And they link you to where the data sets came from online. Some of them are Kaggle data sets. Some of them come from BLS or other government departments, data.gov, things like that. And they're really, really quick jump starts to show you how easy this stuff is once you have the data in the shape that you need it to be in. Again, that's one of the hardest parts through all of this is just getting the data in the shape that you want. One of the reasons for this demo was just that getting a bunch of images off of Google is almost trivial. So there wasn't a lot of data curation or preparation that I did throughout this one.
The work that I'm doing with the Udacity course, we do a lot of transformation of the data first. The transformation that we do are simple.
It's like 90% of your time.
But what it's doing is simply doing cropping. So we're taking a flower and we're cropping everything around the flower.
Mm-hmm.
Or we're picking really just pixels and saying you start with a 256 pixel square image and let me crop it down to 224 pixels, right?
Right.
And then, okay, by the way, let's create a bunch of data. Let's rotate this image, right, 30 degrees, and I'll save that as a new image.
Exactly.
And so then I'm also maybe cropping and transforming. And so basically cropping and rotating and saving again and creating different versions of the same image, but rotated so that you have a new or more additional training data set that's variations of the original training data set.
Yeah, to be able to make comparisons on whether or not the cropped model was different than the uncropped model and that kind of thing.
Whether the rotation is, whether you can still recognize.
Yeah. Is it important? Yeah.
Depending on whatever position the rotated prediction that you put in is going to be in.
Yeah.
It helps train it on that rotated.
Yeah. The data is definitely everything. We even discovered a little bit of that, and there was some good conversation on my last presentation where we were doing the diamond price prediction on which segment of the data I chose as the training set versus the test set. So it was a little bit different than what we did today. It was regression. It was still a supervised machine learning task using regression, but there was some question of if I had randomly ordered the rows in that data set, would that have improved at all? Maybe there was a large segment in the training data set that was not in the test data set, so maybe that skewed it a little bit. We were getting I think I got the model to the point where it was 62% accurate or something like that, which really isn't that great when it boils down to it. But I haven't actually iterated back on that to shuffle the data and see if that would have helped. That's kind of similar to what you're talking about with images, where you're rotating some images and things like that to see what, to feed it into the training model to see if that makes a difference to the actual model. It's a little bit, I guess it's still the same parallel when you're talking about numbers as opposed to images. They're all getting vectorized at the end of the day when they go into the engine.
Vectorized into a tensor matrix. So you're really just talking about numbers on a tensor matrix.
Right, and I'm actually deliberately not using the word tensor. I'm using the word vector. It's a little more. It's easier to comprehend than an actual tensor because they're technically different. But yeah, basically it's just a way of translating all of your data into a number so that you can do math on it.
So I mean, I would say in today's world, you should use a randomized set of data. Your test data should be a randomized set from your body of training data, because you get into the argument today, if you pick a subset of the training data, how do we're saying today that you might be biasing.
Exactly.
The bias set.
You may have no idea you're introducing that bias.
Right, you've introduced a bias because you chose a particular portion of your data set based on some of your criteria.
Yep.
So you've just biased your prediction.
Exactly. Which may result in financial loss from your for your company or what have you. If you're using your system for fraud detection, maybe you only chose the last 2 years worth of data when, fraud was relatively low. Exactly. Yeah, that's right. You should pick the fraud data where you were not guilty of defrauding your company. That way it won't be able to predict when you do it again in the future. And since I'm streaming, I'll, declare that I love my company and I would never defraud them. But yeah, you're absolutely right. There's plenty of opportunity to introduce bias into these systems. So you should definitely always be careful with that kind of thing. That's really all I had, guys. I certainly appreciate everybody coming. I'll post the slides up on the Meetup just so you guys at least have the URLs and things like that if you wanted to check them out. But thanks for coming. Any questions or anything before we start cleaning up? I know we've had a great conversation going along.
If you want to try dog.
My guess is it would probably defer to cat most of the time because that's probably the similar shape. That's probably what it would. That'd be my guess. Is that if you uploaded a picture of any animal into our model, it would probably predict cat more often than toaster, just based on visually how it appears to us, as we look at it, unless like your dog was inside of a box or it was in some type of shape like that and it wasn't able to see eyes, or I imagine that's probably what it's doing behind the scenes, is looking for those facial features and things. Maybe.
It may be a higher prediction.
Yeah.
So the one image with the cat and on top of the toaster,
Mm-hmm.
You had relatively speaking, a lower data set of toasters than you did for cats. If your data set was larger toasters, do you think that probability might have changed then?
It was, so I think actually we can go back and check here. So if we go look at the training images, I think it was 300 toasters and like 260 cats. So the data set was technically larger, but I think it's a good question. What if we had 1,000 images of toasters? Right. Would it be more likely, or would it just make toaster detection or classification more accurate with more pictures of toasters?
See, you got a trick picture here in the middle.
With that dog right there?
A little dog.
Yeah.
In the picture.
Yeah.
It's gonna trip it up, probably.
Yeah, and I'm sure there are others in here. Again, I did not curate this entire. Like, look at that one. Like, I mean, it has the word toaster in it, but there's no actual toaster in there. This one is, a picture of something inside of a toaster. This one is just a logo with. Well, it's got a piece of toast in it. So.
I guess if you were, like when you look, what's that test that the psychiatrist give you?
Oh, the Rorschach tests, right? The ink blot test. Is that what it is?
Yeah.
You're talking about the ink, like the ink blots, right? What do you see in this, picture or whatever?
If you ink block a toaster,
Yeah.
are you seeing a dog,
Yeah.
a cat in it?
Or did we, are we basically just resolving ourselves to be training future psychologists, to make those type of inferences from what these algorithms tell us it is? But yeah, it's.
Because the little feet could be the legs.
Yeah.
The feet of the cat.
Oh yeah.
So you could, and then the knobs could potentially be part of the mouth, right? So.
Definitely. I think we were down to
goes back
cancer.
to your first slide about the different kinds of questions.
Mm-hmm.
This training set and the way this is classified is this an A or B?
Yeah.
Not is this A and B?
Right.
So by putting an A and B thing in there, you're kind of asking the wrong question.
Exactly. So
it's not surprising that you don't
yeah.
get a correct answer.
If I'm feeding in a picture of a cat and a toaster in the same image, what's actually the correct answer? There is no correct answer in this particular model. Yeah.
So it's not surprising that it finds one.
Yeah. And again, it's like if I'm uploading this image and I'm saying, is this a cat or is this a toaster? That's not the right question to be asking of that image, because it is, but like what, if you say it's 100% a cat, you're wrong. If you say it's 100% a toaster, you're also wrong. So, some of that, maybe that's outside the domain of that, of this discussion, or it gets into image detection versus multi-class classification, where we're saying, okay, this is 50-50 cat and toaster, you know, or this is 80-20 cat and toaster, something like that. With the binary classification, you're really just asking yourself, is this A or B or C or D or E or whatever?
Well, but I mean, you really, I mean, and I think that you really, the expectation is that the real training data set was pure cat, not a cat and toaster, where the
Mhm.
test image, then, you know, anything goes on your test image.
Right. You know, do I like? Did I just like in binary? Well, just in classification in general, if we had a subset of data, this is probably not a practical domain. You know, in the business world or anywhere, cats and toasters, cats and dogs probably would have been better. You know, or just animals in general. Maybe I needed to go and find 1,000 images of 10 different animals, and then see, you know, which one it's going to classify various animals as. But then if bear wasn't one of my tags, and I upload a picture of a bear, what's correct? So in this case, you need to know that your input is A or B, and you just need to know which one it is. So I either, like, let's say I was going to use this as a user avatar upload system, and I wanted to detect for nudity, you know, or adult content or something like that. I know that they are uploading a picture of something, and I know that it either contains nudity or it doesn't. There's no other option. It can't contain some nudity. It has to contain nudity or it doesn't. And I needed it, like, that's the sharp question to ask in these cases. In this case, we would have to have a problem that the answer to solve it is this a cat or a toaster and nothing else? In our case of the cat and the toaster, it's a bad input in this case. There's no way to paradoxically answer the question, right? So.
Was there a reason you chose cat versus toaster versus cat versus dog?
Nope. Really just wasn't thinking about it. I was like, you know what? I just wanted to demo the custom vision tools, just to show how easy it was. You know, if we wanted to do it, I mean, it would probably take us another 15 minutes, you know, to get things set up and make sure. And the browser extension, you know, would probably take 15 minutes, you know, to download the images, put them all in the right place, upload them again, retrain the model, go to the postman, hit the prediction. But yeah, it probably would have been slightly more valuable. But again, if you uploaded a picture of a bear or a cat and a dog, what's the correct answer?
Well, but from what you
Same
did,
illustration.
From what you did, though, would you really need to retrain, to recognize the dog?
Mhm.
Or if you really were focused on, is it a cat, would you really need to do anything to your model, your browser, because you have a training set of cats, right?
Mm-hmm.
And so you want to really know if this picture is cat and dog, but you want to feed it dog and cat. So would you even really need to make a change if you wanted to test the dogs against cats? Know that it's cats or not?
Being familiar with the training set, which is usually the actual data that you use to train, which is usually the case. Usually you are familiar with the data that you're feeding in. You want to extrapolate. You know, you're trying to guess at something in the future. So you're being familiar with the data set. I would say yes, it would be problematic, because I would say that 99% plus of the images of cats and dogs would all be classified as cats. I think that they would all be classified as cats.
Oh, you don't think it would recognize any as a non-cat?
Non-cat in our model means toaster.
Okay.
So my guess is that because dogs look like cats, at least more so than they look like toasters, it's going to classify the vast majority of them as cats and nothing as toasters.
To really see what this model does.
Yeah.
And again, as you said earlier, like, there's no debugging tools for this. So there's
Yeah.
really there's no way to look under the hood to see what it's doing.
Yeah.
It's just as likely in my mind that it's not actually recognizing cats at all. It's just
Yeah.
looking for squares.
Exactly.
So-
All we get back is cat probability, tag probability, and that's it, and just an ID. Other than that, it doesn't tell us anything about what it does. So depending on how accurate or how mission critical your engine needs to be, may determine whether or not you use this API or don't use this API, or try to use the ML.NET library to be more specific in training your data so that you can train it and test it in a way that is reproducible and provable. You know, or at least increases whatever prediction you're trying to make already. Let's say you're at 80%, you know, fraud rate, and your prediction with this new ML library you have takes you to 98%. That's good. You know, you can suffer that 2% because you're already suffering that 2% fraud in the subset of 20. So you may need that specificity, or you may need to train that model in a different way using a more specific library. This is a really, really high level demo of this. ML.NET is growing in power like by the week. Their release cadence is only improving at this point. So I would expect a lot more tools even over the course of the next 12 months. And additional examples on GitHub and everywhere else. So, all right.
So you use I had a free Azure account and then it expired and then I was paying for it when I was doing some Azure training.
Mm-hmm.
But in order to get a free account, do I just sign up with another
Yeah.
email address and get another?
Probably. Yeah, you go to azure.com/free, and I'm pretty sure you even get like $200 in credits when you sign up now. So like if you wanted to like really hammer this prediction engine or something like that, you probably could. Like $200 is probably going to get you like millions of trainings and predictions and all of that kind of stuff. If you really wanted to do it, but they hand you the credits when you sign up for an account now, to my understanding. I've had my account for several years at this point, so I can't say what's definitely new. I just have a running budget. Like I just know, like I know I have an Azure bill personally every month just for like experimentation and things like that.
Here though expires though, doesn't it?
You're probably thinking of AWS. There's no free tier in Azure. Azure literally gives you a balance of $200 when you sign up. You use it however you want. Lots of the services, similar to AWS, have a free tier of service, like the prediction, like the custom vision API we use tonight. We're on the free tier that throttles you to 2 requests per second and a certain number of projects and trainings and that kind of stuff. AWS, I think you're thinking of AWS. AWS, you get like 12 months, but that's still only on the free tier of services. As soon as you go above that, so if you want like, the M5 EC2 instance, or I'm probably making these up, but if you want to go up to that medium tier, you're gonna have to pay for it, basically.
So I'm not limited to 12 months with Azure.
No, that $200, as far as I know, that $200 is just, you can use it whenever you want.
But I mean, if you run out the $200, can you still have access to these ML libraries?
Your resources will probably still be there, but the APIs will probably not. You probably will not have access to the APIs if you haven't paid your bill.
Okay.
Akin to the 90s, when you would see a website that was down because the registrar says they didn't pay their bill, so here's this nasty message.
If you run out of your $200 budget, how much do you think just playing around developing like this with what you did today cost in terms of not hitting very many?
This costs $0.
Oh.
What we demoed today, I guarantee 100% cost $0, including the training and the prediction request. So
you're not dipping into the $200.
no. What we demoed today, and as long as you keep your they probably throttle it when you're on the free tier. You actually have to elect to move your API to a standard tier that you pay for. So they probably throttle you to 2 requests per second. If I just wanted to like fire this off a bunch of times, they're probably going to throttle me. Yeah, like I'm getting bad. I need to choose a file. That was why. So if I wanted to fire off a bunch of requests programmatically, they're just throttling 2 transactions per second. And that is and I think that's even capped at like 20,000 or something like that. So after that, you're just going to get like 404s or 500s or something like that in your requests. But they throttle all of that. When you actually up it to the paid tier, that's when billing would kick in. But this is we did everything in a free tier tonight.
You could write like a Python script and every day just have it
Sure.
sample an API. And,
Sure.
And then when you get a positive result, save it.
Sure. Yeah, absolutely. Yeah, I mean, it's ripe for abuse. But I mean, if you have something like that, I don't know, your system's probably not mission critical to the point where you need that kind of stuff in real time. But the next tier up, I'm pretty sure it's like $10 a month. It's like next to nothing, and it gets you a lot more access to it. And it's something that even like I would venture to say it would probably even go beyond like startup context. Like you're in a medium-sized business, you could probably spend $10 or $20 a month and get some real value out of anything under the cognitive services suite, including custom vision API.
Much with the, you had thousands of images. How much could you do with a few dollars?
I couldn't speculate. I haven't actually tried it to see like if the number of transactions needs to be over a certain amount or whatever it is. But at some point, yeah, we would probably break it. The training time would probably break into a paid tier, and we'd actually need to pay for that. But I couldn't guess on like numbers of certain size images. I'm not sure about that. But the Azure pricing documentation is pretty open, and it's reasonably easy to understand. So
Is there a GitHub portal, or have you seen a lot of use cases that have been posted for